Today, we are going to talk about extreme values. Sounds pretty basic, feels kind of basic. Depending on the problems we're dealing with, we're going to see easier problems, harder problems, but the idea itself, not bad, right? So when we're talking about extreme values, what I'm talking about are just maximums and minimums. Okay? With maximums, we know a maximum is going to be, okay, I spelled that right. Maximums are going to be the highest point, the largest value. Minimums are going to be the lowest point. So if we were to kind of look at this graph that I've got up here, right here is the highest point of my graph, and here's the lowest point of my graph. So this is a minimum, and this is a maximum. But there's some clarifying thoughts that we're going to talk about. This is definitely the highest point on this graph. So I'm going to refer to this as the absolute maximum. It is the highest point on my graph, which makes this the absolute minimum on the graph. Lowest point, nothing's lower. But then I've got these little points in here. Got this one and this one. If I were to just zoom in and focus on this portion of the graph, that looks like it's the lowest point. So this is what is called a local minimum. On this piece on the graph, it is the lowest point. Same here. This would be a local maximum. If I zoom in, it's the highest point on that graph. Make sense? Cool. So the difference between an absolute and a local is it the actual lowest point on the graph, or is it just a low point on the graph? Okay, so now we're going to look at some vocab here. As we're, preparing for this unit, we got some new vocab. So the first one we're going to talk about is a critical point. A critical point on a graph that we're going to look at is any time our derivative equals 0 or our derivative is undefined. So this happens when the derivative of our function is equal to 0 or when the derivative of our function doesn't exist. Okay, those are critical points. What's happening at these critical points is potential maximums and minimums. Okay, I say careful, potential max and mins. Not guaranteed, but it's an option. So we'll add that here. Our max and mins, we'll say they can happen at these critical points. So just some visual examples for this. Like for my derivative not to exist. So if we go here, this point doesn't have a derivative. Remember, we can't take the derivative of corners, cusps, or vertical tangents. Right here, the derivative doesn't exist, but it's a maximum. Yeah? So something to take into account. Here's a maximum where the derivative at this point doesn't exist. Same idea if it was a minimum, nothing's going to change there. What about this guy? We have this option. Right here, this is where the derivative equals 0, but that's not a maximum or a minimum. Okay? So that's something else we got to pay attention to. So no max or min there, but it's still a critical point. Other examples, nothing's coming to mind to just kind of help clarify that. So hopefully that makes sense. Okay, last thing we're going to talk about for this video, and then I'll come back with a second video for some examples just to maintain length, is we're going to talk about the Extreme Value Theorem. Extreme Value Theorem. If f is continuous on a closed interval from a to b, so instead of being continuous, it's closed, similar to this. You have endpoints. Okay? If your function is continuous on a closed interval from a to b, then you are guaranteed an absolute maximum and an absolute minimum. So you're going to get both, an absolute max and an absolute min. All right? Guaranteed. So for example, if our function is cut from A to B, here's my absolute max, here's my absolute min. Guaranteed high point, low point. But if I have an open interval and my graph goes forever, well, I have a local max and local min, but these are just going to go forever. There's no max, there's no min. It's going to just continue because it's an open graph. Even if this is one-sided and it looks like this. Well, now I have an absolute maximum, but I don't have an absolute minimum. So if it's a closed interval, you're guaranteed both. Okay, I'm going to come back with some examples.